Hey folks, how we doing today? We're going to talk about writing exponential functions, finding the ending and beginning amounts. So in this case, we're going to be looking at word problems. And the big challenge in word problems is being able to figure out what formula to use, how we can change the words into a mathematical equation that we can solve. So let's go ahead and get started. First, we have this basic one that we've already looked at. Y equals A times B to the X power. And we're going to use this. Oh, you're right, Miss Chrome. We're going to use this one when we use a multiplier. If they give you a multiplier, this is what we're going to use. So make sure you write this down because you're going to need it. Thank you so much. Okay, so suppose a certain cell reproduces itself every 4 hours. If a lab researcher begins with 50 cells, how many cells will be there in one day? Okay, so what we're going to do is we have a multiplier, and because it's talking about reproducing itself, we're going to multiply over and over. We're going to double it. Okay, so that means we know to use this formula, and now all we're going to do is we're going to take each part of the formula, starting with the end here, and figure out if we know the ending amount. And if we look carefully, it says how many cells will there be at the end. So no, we don't know what the ending amount is. That's going to stay Y, which means we're probably going to know everything else. So we're going to look now for our beginning amount, and we read through the problem, and it says that we begin with 50 cells. Awesome. So that means that's our beginning amount, 50. And now we're going to find our multiplier, and the word that tells us what we're multiplying by is we're reproducing, and I think I mentioned it earlier. If it's reproducing, it's doubling. Each cell is going to double itself, and so that means we're multiplying by 2. And so now all we're going to do is figure out how many times we're going to multiply by 2. Well, it says that it does it in 4 hours, and we want to know how many are going to be there after one day. So the big question is, how many 4-hour periods, because that's how long it's going to take to double, how many 4-hour periods are there in one day? Well, there are 6 4-hour periods in one 24-hour period. So now all we've got to do is raise 2 to the 6th power, and then multiply that by 50, and we get our answer is 3,200 cells. All right, let's try another one. All right, the coronavirus is a terrible pandemic. Today, 5 residents in Charlotte, God, we wish, right? 5 residents in Charlotte have it. Each week, the number triples from the week before. How many will have it in week 5? Now, you mentioned the word triples. That's a multiplier, so that's how we know we're going to use this formula. So we're going to start by looking for the ending amount. Well, it says clearly again, how many will we have in week 5? That means we don't know the ending amount. So we're going to look for now the beginning amount. Well, it says that there are 5 residents that have it at the beginning. So that's going to be our beginning amount. And then we have to look for our multiplier. Well, we mentioned that already again. When we're talking about tripling something, we multiply by 3. So that's going to be our multiplier. And then all we got to do is find out how many times we're going to multiply by 3. Well, we look carefully at the problem, and it says that it multiplies every week. And we're going to go 5 weeks. So that means we're going to raise it to the 5th power. So now all we're going to do is do 5 times 3 to the 5th, which is going to end up giving us our answer of 1,215 people having the virus. Okay, now we've got that formula at the bottom, and it's awesome when they give you a multiplier. They'll use words like double or half or triple or something like that. However, sometimes they don't give you a multiplier. And instead of giving a multiplier, what they do is they give you some kind of annual rate of increase or decrease. And in that's the case, we're going to use this top formula. Now, that's very similar. It's got an ending amount of Y, just like our other one did. And it's got an initial amount of A, just like our other one did. The difference is there is no multiplier. Instead, we've got to make our multiplier. And the way we're going to make the multiplier is we're going to take our rate of change. It's usually going to be presented as a percent. We're going to change that percent to a decimal. And then what we're going to do is if it's decreasing, we'll make it minus. And if it's increasing, we'll make it positive. And we're going to add 1 to it. And that's going to become our multiplier. And then x, like we did before, is going to be how many times that we have to multiply by. So the formulas are similar. Its only difference is that when they give you an annual rate, a percent increase or decrease, we're definitely going to need to use this top formula. And you were right, Miss Moreland, we had to write that down. Write the formula down and write down that we're going to use this whenever they give you an annual rate of increase or decrease. Okay, so let's try one. Find the account balance to the nearest dollar if the account starts with $100, has an annual interest rate of 4%, and the money left in the account is for 12 years. Okay, well now again, you notice how they give us an annual interest rate of 4%? That tells us we're going to use this formula. And so now we're going to start at one end. We're looking for the ending amount. It says find the account balance. So that means we don't know what we ended up with. So we're going to now look for what we started with. Well, it says the account starts with $100. Okay, we'll put that in there. Now, the one, it's going to be a 1. We got to figure out what the rate is. Well, the rate is 4%. It's annual interest. So what we're going to do is we're going to divide 4 by 100. That's going to give us 0.04. It's increasing, so then we're going to add 1. So it's going to be 1 plus 0.04, or 1.04 if you want. And now we're going to figure out how many times we're going to do this. Well, this annual interest rate, how many times are we going to compound it annually? Well, it says we're going to do it 12 years, every year for 12 years. So we're going to do it 12 times. And see, now all we got to do is find out this. You can use Desmos. A lot of times we forget that it's a calculator, actually, and because we do so much graphing on it. But if all you do is type it in and then press enter, you're going to find the answer here is 160.10. And if we round to the nearest dollar, it's going to be 160. All right, so now another problem. It says our original price of our tractor is $65,000. The value of the tractor decreases at a steady rate of 12% every year. What will be the value of the tractor in 5 years? Okay, once again, you'll notice how they give us a decrease, a steady rate of 12%. That tells us we're using this formula. There's no multiplier. We're going to have to make one from this rate. So now we're going to start with the ending amount. Well, it says that what will the value be later, so that means we don't know the ending amount. It says the original price of the tractor was $65,000. That must be our beginning amount. And then it says that the rate, well, that's 12%, but it's decreasing. So we're going to make it negative 0.12, 12 divided by 100, 0.12. And then we're going to add our 1 to it. And so now all we're going to do is figure out how often that's going to happen. Well, it's going to happen every year for 5 years. So that is going to be the exponent right there. And again, if we go to Desmos and type that in, we're going to find out that the value is going to be $34,302.57. Another problem. Hannah, she's got $5,000 in her account after 4 years of investing. Her account increased an average of 2.5 each year since she opened it. How much did she start with? And see, as we're reading the problem, we need to be thinking about the pieces that they're telling us. They give us this increase of 2.5%, so that means we're definitely going to use this formula. That's how we know. And we're going to start by looking for the ending amount. Well, you'll notice that it says we had $5,000 in her account after 4 years. So this must be the ending amount. And then we're going to look for the beginning amount. Well, it says how much did we start with, so that means we don't know the beginning amount. We're going to leave the A there. And again, we're going to look for our rate. Well, that's pretty easy to find. It's a percent. Now keep in mind, we're going to change it to a decimal by dividing it by 100. 2.5 divided by 100 is 0.025. It's increasing, and interest is always going to be increasing. So anyway, we're going to say it's 1 plus 0.025. And then we're going to find out how often. Well, it happens every year, and it happens for 4 years. So that means that we're going to raise it to the 4th power. Now, in this case, we've got to get the A by itself. And so A times 1 plus 0.025 to the 4th power. If I just divide both sides by 1 plus 0.025 to the 4th power, that's going to get the A by itself. And all I got to do now is put the 5,000 divided by 1.025 to the 4th power in my calculator, and I get 4,529.75. Okay, so now we've got 2 more formulas, and yes, it will be an awesome idea if we wrote these down and when we're going to use them. They're similar formulas to what we've seen before. They're always going to be used with money, though. And so let's go ahead and write these down. The first one is we're going to use this formula whenever we talk about interest and money, and we talk about compounding more than once a year. Remember before we were talking about an annual interest or an annual change? Well, this is going to happen more than once a year. And so that n in the formula, that's going to be the number of times in the year that we compounded. If it's monthly, that's going to be 12 months in a year. It's going to be a 12. If it's quarterly, where there's four quarters in a year, so then that n is going to be a 4. We're going to divide the rate by how many times we compounded in a year. And then we're going to multiply the years in the exponent by that same thing. Anyway, the other formula, it's going to be used again with money, but it's going to also be used when we use the words compounded continuously. And it's going to say those exact words. Hey, if we're compounding continuously, then you're going to use y equals p times e to the rt. Now, let's look at this formula first. We've got the ending amount, just like before. We've got the beginning amount, just like before. We don't have a multiplier, but we're going to build it just like we did with the interest rate. The only difference is we're going to take that interest rate and divide it by the number of times we compound every year. And so then we're going to take the number of times we multiply this or do this compounding. Well, think about it. If we did it for 2 years, but we did it quarterly, well, that means we did it 4 times every year for 2 years. That's going to be 4 times 2, or 8. And that's how we got to multiply the number of years by the number of times we compound in a year. Anyway, it'll make a little bit more sense if we do an example. The other one, it starts off with y. That's the ending amount. Instead of having a for our beginning amount, we're going to use p. It stands for principal. But this first letter is going to be our beginning amount. E, it's a number. It's like pi. It's an irrational number. It's found on most calculators next to the ln button. Or if you're using Desmos, if you just type the letter E, that's the number that's going to come up. You don't got to worry too much about it. You don't have to even memorize the number. Just know that E is a number. It's not a variable. And we use it a lot of times in financial formulas. And then R, that's our interest rate. And again, we're making it a decimal, but we're not going to add 1 to it. And then T, it's always going to be the number of years. Okay, so let's go back and try, we're going to try one with this y equals p to the ERT. Now, keep in mind, we only use this one when the problem says we're compounding continuously. And Ashley's got an investment account with a balance of $3,500. Over the past 5 years, she's had an interest rate of 2.5% compounded continuously. They're not going to hide it. It's going to be right there. So anyway, how much did she put in the account 5 years ago? So because it's compounded continuously, we know we're using this PERT formula, and we're going to start by finding our ending amount. Well, it says how much did she put in 5 years ago, so that means we don't know the beginning amount. This must be the ending amount, so let's put that at where that goes. We already established we don't know what the beginning amount is, so we're going to leave P alone. E is a number. It's not something you have to look for. It's just a number. So we're just going to leave EE. So we do need the rate. Well, that's 2.5. We're going to divide it by 100. So that's going to be 0.025. And then we're going to have T. Well, that's how many years that we do this. Well, the problem says we do it for 5 years. So that T is going to become a 5. Now, we've got to get the P by itself. Now remember, the E is being raised to this exponent of 0.025 times 5. The P times the E. So all we've got to do is divide both sides by E to the 0.025 times 5 power. That's going to get our P by itself, which is what we want. We're going to type in this other thing in the calculator. And again, if you use Desmos, it's going to look just like that. Again, using E, it's on the keyboard like the letter E. And then we get our answer is $3,088.74. Now, the other kind of problem we're talking about is when we're compounding more often, but it's not continuously. It's going to be monthly or daily or quarterly. And so in this case, it says that Hannah's got $6,000 in her account. It's got an interest rate of 3% compounded monthly. And so that's how we know we're going to use this formula here. And it wants to know how much would be in the account after 4 years of investing. So we start by looking for our ending amount. Well, we read it. We found out that we want to know how much is going to be in the account after. So we don't know the ending amount. We're going to find the beginning amount. Well, it says that she put $6,000 in there in the beginning. So that must be our beginning amount. Our interest rate is 3%. We're going to make that a 0.03. And we're compounding it monthly. So we're going to divide that by 12. And see, now our t, that's going to be the number of years. That's going to be 4. And then we're going to multiply it by 12. So it's going to be 4 times 12 because the n is a 12. And see, you don't have to even go crazy and do a bunch of stuff. This is all you need. If you type that in exactly the way it looks, type it in exactly the way it looks in the Desmos, it's going to give you your answer, $6,763.97. Okay, so that's all I got for you today. Keep in mind, when we're looking at these word problems, think about these different formulas. You've got a situation where they got a multiplier, we've got a formula. We've got a situation where they have an annual interest rate, and we've got a formula. We've got a situation where it's compounded more than once a year, monthly, quarterly, whatever. So that's when we're going to use the one we're looking at right here. And then the other last one is when it's compounded continuously, and that's when we're going to use the PERT formula. Okay, so thanks for watching. I hope this helped.